Okay, this video is going to get through the remainder theorem and the factor theorem. Alright, so first is the remainder theorem. Alright, the remainder theorem says if you have a polynomial function f of x and you divide that polynomial by the polynomial x minus some number k, so just x minus some number, then the remainder is the same thing as if you were to evaluate the function f at that particular k value that we have right here. Okay, we'll see an example in just a minute. Alright, we'll do the factor theorem as well. Alright, so the factor theorem says the polynomial x minus k is a factor of your polynomial f of x if and only if f of k is equal to 0. Alright? Or if you were to do division and divide x minus k into f of x and your remainder turned out to be 0, because that's what the remainder theorem was saying here, then x minus k would be a factor. Okay, again, if you're still a little shaky, hold on. Okay, so a little note. All right, x minus k is a factor of f of x if and only if k is a 0 of f of x. And remember what it means to be a 0 of a function. A 0 of a function is any number that when you evaluate it into your function, the value of the function turns out to be 0. Okay, and that's what this thing right up here in the factor theorem is saying. If you evaluate your function f at some k value, and then that function value goes to 0, then x minus that k value is a factor of your polynomial. All right, so enough of the theory stuff. Let's do an example. All right, let f of x be 2x cubed minus 3x squared minus 5x plus 6. So the question is x minus 1 a factor? Well, one way to do it would be to find f of 1, because your k value here is 1. Okay. Well, what's f of 1? All right, so you plug 1 in for all the x's, and you get 2 minus 3 minus 5 plus 6, and that all goes to what? Everybody get that? All goes to 0. All right, so because f of 1 is equal to 0, then x minus 1 is a factor of this polynomial f of x up here. Now that's fine and dandy, but we can actually do something else that would be even more useful. All right, so the other thing we can do is we can do the division. We can divide x minus 1 into f of x here, and if the remainder turns out to be 0, then x minus 1 is a factor. Okay, and we're going to use synthetic division because, well, we can, right? It's x minus a number here. So let's put 1 inside our little half box, and out to the right here we have 2, negative 3, negative 5, and 6. Skip a line, draw a line, bring the 2 down, and go. 1 times 2 is 2. It's negative 1, negative 1, negative 6, negative 6, 0. Okay, and we got 0, just like the remainder theorem said we would get. That the if you divide x minus 1 into f of x here, then the remainder, 0, is the same thing as if you were to evaluate the original function at that k value 1. And they are the same. Everybody see that? Okay. Now with the factor theorem, we know that x minus 1 has to be a factor. So if you'd like to, just say yes, we're excited, yay. Okay, it's a factor. And so then your quotient down here would be 2x squared. Remember, you started with x cubed, 2x cubed, so this is cubed. So this is squared, 1 degree less, and then you go in descending order. So minus x minus 6. Right? So really what we have now is f of x has been factored into x minus 1 times 2x squared minus x minus 6. Everybody see that? If you take this quotient and multiply it times x minus 1, the divisor there, you're going to get back your f of x, 2x cubed minus 5x plus 6. But now let me ask you, does 2x squared minus x minus 6 factor? Okay. Yes, it does. So we have x minus 1. Then 2x squared minus x minus 6 factors into 2x plus 3 times x minus 2. Everybody see that? Okay, so I'm writing it down here in this completely factored form. We've just taken a third-degree polynomial and factored it into a product of three factors. And these three factors down here, look at each part. X minus 1, 2x plus 3, and x minus 2. Those are all linear expressions. Everybody see that? In fact, all three of these things down here are called linear factors. I'm going to write that up. We've got linear factors. Okay, we like to write, if we can, we like to write our polynomials as a product of linear factors. One reason why is now we can read off all the zeros, right? Everybody see that? So we've got real zeros. So we have real zeros. Okay, real zeros are what makes the y value 0. Okay, so everybody see that if x was 1, it'd make the y value 0. We already figured that out over here. 1. Okay. If x is 2, everybody see that? This would go to 0, so the whole thing would go to 0. And if x is, what's this one? Negative 3/2. Right? If you set each one of these factors equal to 0, you'll get these three numbers down here. And these three numbers are called the real zeros of our function. And all that means is if you take any one of these three numbers and plug them in for x up here, then the y value goes to 0. Great. Now what does that mean graphically? That's right. This is where we hit the x-axis. Right? If we were to graph this function, we would hit the x-axis at 1, 0, 2, 0, and negative 3/2, 0. Follow me? Okay, so this process is called linear factorization. You're trying to write this polynomial, this original polynomial, as a product of linear factors. And one way to do that is do synthetic division, get a remainder that's 0, and then take your quotient, and then you keep doing the synthetic division for as long as you need to. But as soon as you get your quotient down to a quadratic, well, then you can try to factor it and see what happens. Does that make sense? All right, so that's it on the remainder theorem and the factor theorem. So study well, and please let me know if you have any questions.